Welcome to the Turf Zone podcast. This episode features the article Testing Ground featured in Tennessee Turfgrass magazine. UT turfgrass researchers have invented a device to test the playability of football fields, soccer pitches, and other surfaces, with the goal of keeping athletes safe. In 2018, the NFL scheduled a game for a neutral site in Mexico. Though the field had passed mandatory tests like surface hardness, the league's Players Association had concerns about the safety of the field. So they turned to distinguished professor of turfgrass science and management John Sorochin to represent their interests. Sorochin advised that there were too many inconsistencies in the field and that the lack of rooting was a serious issue. He argued that an inconsistent and unstable surface is an unsafe surface, and his advocacy helped get the game moved to a safer field. For Sorochin, the experience revealed the need across multiple sports for a better way to test the playability and compliance of natural grass surfaces. Together, he and Kylie Dixon, BS 12, MS 14, PhD 17, researcher and co-director of UT's Center for Athletic Field Safety, invented a solution that has surpassed its original goal, the Flex device. This portable machine realistically simulates the motion of an athlete's foot striking the ground, using a 3D printed foot outfitted with a real cleat. There were machines out there to test artificial turf. Years before, Dr. Sorochin helped AstroTurf develop one, Dixon says, but nothing was specific to natural grass. We also wanted to go beyond the static vertical load, rotational, and slide tests that existing tools used, he continues. We put sensors around the 3D printed foot and ankle to measure energy that would be transferred back to the athlete. This makes Flex unique. Development of the Flex device reflects the driving force behind sports turf research at UT, the human impact of athlete-surface interactions. Our tool to measure what athletes would feel on natural grass has turned out to be equally applicable for synthetic turf, running tracks, even basketball courts. All surfaces but ice for hockey, to understand the effects on athletes, Sorochin says. A team effort. Producing the Flex device was interdisciplinary from the start. Sorochin and Dixon hired metal workers to build their device, mechanical engineers to run calculations, and a recent UT computer science graduate to develop software to collect and interpret sensor data. UT kinesiology and biomechanics experts scientifically validated the device at the biomechanics lab. Flex struck the force plate like a human athlete would, Sorochin says. We learned how to calibrate it to simulate foot strikes for different-sized athletes, from a 350-pound NFL athlete down to a 35-pound kid playing soccer at school. They partnered with UT Athletics for real-world testing. After football games at Neyland Stadium, researchers would collect data from more than 70 spots across the field to form a comprehensive picture of its condition. Neyland is probably the most tested stadium anywhere, Sorochin laughs. And when the Lady Vols soccer team needed to change cleats, the Flex device informed that decision by measuring the load different shoes put on players' bodies. Being a Vol means being part of a team, Sorochin says. So many Vols have helped us develop and test Flex. From concept to commercialization. Early prototypes involved manually ratcheting and releasing gears. When Sorochin and Dixon collected feedback from field managers and student researchers who used the device, everyone agreed there were too many components and too many data points. To make a real-world impact, Sorochin says, it had to be simpler for field managers and other turf professionals to use, understand, and benefit from our device. We also needed to scale up in terms of production and audience. UT and UT Research Foundation played important roles in accomplishing that and commercializing our invention. In 2024, Sorochin and Dixon received the inaugural Chancellor's Innovation Fund Award. They focused those funds on automating the device and streamlining the user experience. UT Research Foundation helped them patent their technology, connect with business advisors, and put their product on the market. Today, users set and release the gears with the touch of a button. The screen displays 3 key data points: surface traction, surface hardness, and amount of energy returned to the athlete. The software automatically generates a report complete with summary, graphs, and a heat map highlighting inconsistencies across the field. International impact. The Flex device's credibility has grown with every sporting venue the team has tested over the last 5 years. 130-plus stadiums connected to the NFL, MLB, and other professional and college leagues in 5 countries. FIFA, soccer's international governing body, has seen the value of the Flex device firsthand during a 5-year research collaboration with UT. Billions of FIFA World Cup 26 viewers will soon watch top athletes play on natural grass pitches developed by Sorochan's research team. Several of the host stadiums for the FIFA Club World Cup 2025 used a first-of-its-kind, shallow profile pitch. It was a wow moment when Flex first demonstrated that the shallow construction method we were experimenting with performed the same as a standard pitch, which has 12 inches of sand underneath, Sorochan says. This shallow profile could enable host stadiums that typically use synthetic turf to quickly and cost-effectively install safe natural grass pitches for the World Cup tournaments. At FIFA's request, Sorochan's team used the Flex device to gather field data before and after each Club World Cup game in summer 2025. They'll likely use Flex in the same way during FIFA World Cup 26 to inform real-time field management decisions that protect players and ensure uniform conditions across all 16 host stadiums. FIFA has incredibly high standards for these pitches, Sorochan says. Flex is the right tool to make sure their expectations for consistency, safety, and performance are met. In May 2025, global pitch management solutions company SGL purchased the Flex device product rights. SGL is an industry leader expanding its portfolio of resources and tools for improving sports fields, Sorochan says. They invest in quality and R&D. Flex was a great fit. Flex represents the very best of UT, ideas that are generated and implemented locally and go on to change the world, says Deb Crawford, Vice Chancellor for Research, Innovation, and Economic Development. By leveraging the Chancellor's Innovation Fund and partnering with private industry, Dr. Sorochan and his colleagues have expanded their impact, ensuring that UT innovations continue to have a profound impact worldwide. Dixon is directing product development for SGL Flex Systems. I'll explore questions to make it even more user-friendly, like could it be robotic? Could we put an electric motor drive on it? Are we getting the right data for different sports? This device will make all sports surfaces safer for all levels, from young kids to professional players, Sorochan sums up. UT's support made this impact possible. Now SGL is making it global. Delve into UT's research to create the best and most consistent pitches for FIFA World Cup 26. You've been listening to the Turf Zone podcast. Follow the Turf Zone on X, Facebook, and LinkedIn, and visit www.theturfzone.com for all things turfgrass, featuring podcasts, magazines, events, and more.